sheets. I'm going to record here. I don't want to touch this now. I'm afraid it won't record. So I'm recording on my iPad. Where was I? In chapter 3, in order to solve an equation with two variables, guess what? We have to have two variables. You can't solve an equation with more than one variable, just having one equation that's not working. In college algebra, you're going to learn how to solve systems of linear equations with three variables. Cool. And if you go into higher level math courses, I took in pre-calculus, you're going to do matrices, and then you may have 4 or 5 variables. You need 4 or 5 equations. So chapter 3, we're going to solve these algebraically, either with substitution or addition method. In chapter 2, we're just graphing. So before we can graph, we have to look in 2.1 at some preliminary definitions and everything. You may have, I hope you have seen them before, but 2.1 is just on the rectangular coordinate system. So rectangular coordinate system, I had some points here already and I didn't want to delete them, really consists out of a horizontal axis, which is called the x-axis, and a vertical axis, which is called the y-axis. So what you have here are really 4 equal sections, areas, and we can determine points here, ordered pairs. That is really one way how we started to create maps back in the day, you know. They came up with the coordinate system and then they plotted points, and that's how maps were started. So each section is equal and each section has a name. We're starting in the upper right corner, and that is called quadrant 1. In quadrant 1, you have x coordinates that are positive and y coordinates that are positive. So quadrant 1 would be right here. Quadrant 1. And then we go counterclockwise. So Q2 is right over here. Then we have Q3. And usually we use Roman numerals. And here is Q4. So we have 4 quadrants. Now, in quadrant 1, what we're really trying to plot is what is called an ordered pair. An ordered pair consists out of an x-coordinate and a y-coordinate. So we have an ordered pair, x and y. In quadrant 1, this point, this ordered pair, has both positive signs. In quadrant 2, the signs of our ordered pair is a negative x-axis and a positive y-coordinate. In quadrant 3, what do you know about all the signs in quadrant 3 of our x and y coordinate? They are both negative, and in quadrant 4, we have what kind of sign situation? X is positive and y is negative. Okay. Now the green point here, smack in the middle, where the x and y axis intersect. How's that point called? That is the origin. And people online, you can chime in too. What are the coordinates of the origin? Coordinates of the origin? 0, 0. Thank you, Alexander. 0, 0. Okay. Now you see I plotted a couple points here, and I want to ask you, what is the ordered pair for point A? Now we have our x and our y-axis just like a number line. To the right is positive, to the left is negative. So here's a -4, not to forget. So what are the coordinates for point A? We have an x value that is 3, and if we go across, we have y value that is 3 as well. The x coordinate is 3, the y coordinate is 3. Where's B? B is right here. Who can label this point? Would it be 0, 3? And I heard that from Elijah here as well. The answer is no. 0, 3. It would be 3, 0. The x value comes first. So if we move on our coordinate system, we move to the right 3 units. That's our x value, but that we're not moving up or down with our y value. So this point is 3, 0 for B. But now we are with C. Okay, Elijah, now it's your turn. What is the ordered pair? Oh, I already wrote it down here. The ordered pair for point C right here would be 0, 3. You're not going to the left or right, you're just moving up 3 units. C, D. Okay, let's take a look at D. What are the coordinates for point D? I'm just waiting for Chloe said -1, -2. That is correct. How about E? Coordinates for point E. 0, -5. And F is over here. That is 5, -2, and there's a G. Why not? -4, 2. These are your ordered pairs that are just so made up. Now, the points on the axis, the 3, 0 actually has a special name that's called the x-intercept. And if I were to graph a line, and 0, 3 would be the y-intercept. What else do we have here? I think I talked about everything. Who can tell me in which quadrant, okay, here we go. In which quadrant is the point -1/2, 3/4? In which quadrant is the point -1/2, 3/4? I just made that up. That would be in Q2. Yes, Alexander. What? No, I was here. Alexander's here. I know you're Alexis. Yeah. Okay. No, I was talking to him. Yeah, 2. Yeah, that is in quadrant 2. In which quadrant is the point -48, -123? I just so made that up. That would be in quadrant, I see hands going up, 3. That is correct, and I already plotted it in quadrant 3. One more for why not. These are some questions you have for homework in 2.1. In which quadrant, or maybe it isn't, where is the point 0, 4 located? Is that in a quadrant or it's on the axis? On which axis is it located? 0, 4 is located on the okay, I hear x-axis or I hear y-axis. Chloe said y-axis 0, 4 is actually right above the 0, 3. So here that red dot is the point 0, 4, and that would be on the y-axis. Y-axis. That is on the y-axis. It's not located in a quadrant. It's located on the y-axis. Okay. Well, I just wanted to give you another point. I think we're good. Here's x. I always like to label them y, and then I think we're good on this. Okay, this is a problem, or again, A, B, C, D, E. You have points given, and you have to label them. That's on page 98. So let's do just 2. Why not? How about D? What are the coordinates for point D? 4, -3. I'm not sure if it is too dark, but we can see it okay for right now. I took a picture. What about E? -2, -2. Okay. So, and let me just finish it. Why not? A is -1, 3. B would be 2, 1. You always read the x value first and then the y. And C would be what? 0, -3. So you have those kind of problems in your homework where you just have to label the ordered pairs. Here's another one. Now let's actually look at the general form of the linear equation with 2 variables. Again, in order to solve this one, we have to have 2 equations. So right now we're just graphing, looking at it, and making it look pretty. So the general form is ax plus by equals c. So A, B, and C are our coefficients, or just real numbers, and then we have x and y, which is our ordered pair, that when we plug it in, hopefully will give us a true statement. So if we plug in a value for x and y into this equation, and it comes out to the number c, then we know that x and y value is actually a point on the line. If it is not equal to whatever it's supposed to be equal to, then it would not be a point on the line. So the first couple problems in your homework, they're asking you if this point is a solution to the equation. So let's take a look here. Determine whether the ordered pair is a solution to x plus 4y equals -8. Now I have to give you the ordered pair. And the first ordered pair we're going to look at, you tell me, is it a solution? Is -2, -1. Does this one work? How do we do that? I'll show you one and then I'll give you another one. This is your x and y value that you now have to plug into the original equation that I gave you here. And if it's equal to -8, if the left-hand side is equal to the right-hand side, then we know, yes, it is a solution. So x replace with -2 plus 4 times -1. Guys online, say yes or no. What do you say here? We have a -2, a -4 times a -1. 4 times a -1 is a -4. -2 minus 4 is -6, which is not equal to -8. So the answer to this question here would be no, it is not. So it's not a point on the line once we start graphing. Okay, let me give you another one, and you tell me 4, -3. Is 4, -3 a solution? Yes or no answer. Problem like this will be on your next test, I can tell you already. So I'm going to give you a minute here, and you tell me if this is a solution, and then we do one more, -14 3/2. Okay, I see you guys saying. Four -3, is it a solution? Okay, let's plug it in. That's what the people online said. 4 plus 4 times -3. 4 plus a -12 is indeed a -8, which is a -8. So the answer here is yes, this one works. How about the next one? -14 plus 3/2 times 4. Is that -8?
Yes.
-14 plus 4 times 3/2. 2 goes into 4 twice, so -14 plus 2 times 3 is 6. And that is, who's talking? Me. We have an echo here in the classroom. Now it's gone. Okay, are you recording me? We're all recording me? Okay, hello, how are you doing? Okay, so these 2 points are actually true. If I were to plot this line, I could just plot these 2 points, and that would give me a straight line. Speaking of, before class started, I was talking a little bit about some mistakes that may have been made on the test, and just looking at this fraction here, 4 times 3/2, reminds me that sometimes I did not see, like, you reduced it correctly, but then for whatever reason you just wrote 3 instead of multiplying the 2 times 3. So that did happen. I did see that as well on the test. Okay. Now we're going to graph these beautiful straight lines. And the method to graph a linear equation is through a t-table, where we have x, y values, and we have to fill in whatever's missing. Not my preferred way, but the book shows it first, so I'm going to show you 1 or 2. I don't really ever use the t-table per se in graphing lines. I use the x and y intercepts. That's also in 2.1. If it's easy, if they are multiples of each other, then it's real easy to graph these 2 points and you connect the dots. But really what I mostly use is the 3rd point, which we're going to talk about in, I want to say 2.3. 2.3 shows how to use the y-intercept and the slope to graph a line. And that's really what I use for most of my graphs. It depends on the problem. If I have multiples, I just use x and y-intercept because that's real simple. If not, I use the slope and the y-intercept. So today we're only going to look at the t-table method, where they give you a table in the book and we connect, we fill in the missing links and then plot the points, connect the dots, and make a beautiful line of it. Okay, let's take a look at this problem number 16 in the book. Is 4x plus 3y equals 6. That's on page 98. Oops, what happened? Okay, the t-table is given to us, and we have a 2 here, we have a 3, and we have a -1. So the book, or whoever wrote the book, which used to work here, by the way, she already placed in values for one of the ordered pairs for one of the coordinates, and now we have to find the missing one to actually make sure we have a point that's a true solution. I had to let somebody in. Here you go. And we can plot that line. So how do we do this? Let me show you the first one. We're missing the x-coordinate. The y-coordinate is given. What have I been saying? We can only solve an equation with one variable. So we're replacing the y with 2 and then solve for x. So that would be 4x plus 3 times 2. Can I write 6? 3 times 2, you know where that's coming from. We're putting the y in there, equals 6. Oh, that brings me to another test question. I think number 2 or 3 on the test. Okay, let's finish this one here first. How do we solve this? Okay, Alexander already has the answer here. We're going to subtract 6. And we get 4x equals 0. And then there was a similar problem like this on the test, where you came across something that's equal to 0. And I did see an answer of no solution. That is incorrect. If we divide by 4 in this case here, x is equal to 0, and that is a number. That is a solution. So your x can be 0, is just the same value as x equals 2 for that matter. So be careful when I give you the test back, look at that again. I did see some wrote no solution, which actually it is a solution. It is 0, 2. And if you have a solution, then it's called a conditional equation. Okay, that's our first point. Let's take a look at the next point. The next point, x is given. So we're replacing the x here with 3. 4 times 3 is 12. Plus 3y equals 6. So then you subtract 12. 3y equals -6. Divide by 3. Y is equal to a -2. So the y-coordinate of our second point is -2. Now we're going to use the third point. The third point, just to make sure we have a straight line. Bless you. Usually 2 points is enough. The third point just tells us we have a straight line. Okay, 4x minus 3. 3 times 1 is -3 equals 6. Add 3. I want to graph it here. That's why I'm writing it over here. 4x equals 9. Divide by 4. X equals 9/4. Yes, sometimes you can get fractions here. Now, if I graph them, which I'm about to do, then I usually change these fractions into a decimal because that gives me a better way of plotting the point. Okay, let's plot the point. 9/4 as a decimal is what? What? 2.25, yes. -1, -2. Okay, let's plot the point 0, 2. 0, 2 is on the y-axis right here. 3, -2 is right there. If I wanted to connect the dots now, I can. 2.25, -1, just to make sure I really have a straight line. And you know, with guesstimating a decimal is always a little tricky. So here you go, this looks good. Connect the dots. Off you go, done you are. Beautiful. There's your straight line. If you get a squiggly line, you're doing something wrong. A point is misplaced. Any questions? No? Okay, let's do number 22. 22 is 5x plus 3y equals 15. Now, they actually, for these, they didn't give us a table anymore. So, for whatever reason, I put 3, 0, -3 in there. I think there was a reason for it. You can plug in whichever value for x that you want to and then find the missing y value. So what I'm trying to say is sometimes you may have to do your own t-table, and then you have to plug in values that you give yourself, and then you find the missing one. This particular problem, I would just use x and y intercept, because those are all multiples of each other, makes it easy to do. But let's do one more here with those numbers that I have. 5 times 3 is 15 plus 3y equals 15. And that's why I picked those values. You subtract 15, you get 3y equals 0, and that means y is equal to 0. That is an x-intercept. And if x is 0, well, if x is 0, the whole 5x is 0, and that's going to go away. What you have left is 3y equals 15. Divide by 3, and that makes y equal to 5, and that is your y-intercept. X and y-intercept I'm going to talk about in a second, but they are easy to find here because 5, 3, and 15 are multiples of each other. Jordan, you typing something? Let's see what you're saying. Did you get the answer for -3? Let's plug it in. -3 times 5 is -15. When are we plugging the values from the table into? Do we have to show all the work when we are solving, or can we shortcut like we did on the last one? You can shortcut like I did on the last one. Yes, you can. Okay? Cool. So -15 plus 3y equals 15. Actually, Jordan, since you say it, I'm going to call it the cover-up method. I actually cover it up and do a shortcut version. You can't see that, me doing here online, but maybe I could, no, I can't. But that's how I call it. I call it the cover-up. 3y equals 30, divide by 3, y is equal to 10, and there are your 3 points. Do we have enough room? Y is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let 1, 2, 3, 4, 5 here. 1, 2, 3. 1, 2, -3. Plot the points. 3, 0. 0, 5. -3, 10. They all line up more or less. Connect the dots. Here you go. Okay? Any questions? No? Nobody? Questions? Everybody good? Now let's talk a little bit about the x and y intercepts. So here is our rectangular coordinate system. And if I just draw a graph like so, straight line, then we have y-intercept here, and we have an x-intercept over there. Can you see that? I hope you can. Let me make it a little darker. It's hard to see here. Blue on blue. There you go. So this is the y-intercept. And when we have the y-intercept, what do we know about the x-coordinate? The x-coordinate is always 0, and the y-coordinate, let me call it y, is whatever the number is. Over here, we have the x-intercept. And what do we know about the y value? Is 0. So in order to figure out what the x and y intercept is for the x-intercept, you said y equal to 0 and solve for x, and for the y-intercept, you said x equal to 0 and solve for y. I kind of do make a little t-table, but automatically I put in a 0 here and a 0 there, and that color is not good to see. And then I fill in the missing coordinates, and these are basically my x and y coordinates. So somehow I make the t-table, but just with 2. Okay, let's take a look at number, whatever, that's not a number, I probably made that up. Graph it using the x and y coordinate. And that's what I call the cover-up method. So I draw my little t-table here. Right away I put my zeros in there. And then, so if x is 0, and I do this here in class, you can't see it, I cover up the x term. So a cover-up method, you just cover it up. All you have left is 4y equals 8. And that's easy to solve. The same with the y. If y is 0, this one's gone. And all you have left is 2x equals 8. So if x is 0, we have 4y equals 8. Y is equal to 2. And the other one is 2x equals 8, and x is equal to 4. There you go. That's all you need. 2 points. 2 points. Connect the dots. Off you go. I always like to label them. I don't know. I do that. So here is 2. 1, 2, 3, 4. Here is 4. 0, 2, 4. Make your dots. Done you are. So if all 3 numbers are multiples of each other, that's the easiest way to graph them. Cover them up and find the points. Okay, how about this one, number 34. Find the x and y intercepts. Okay, you guys do it. Online people, tell me what the x and y intercept are, and then graph it. You can't really show me your graph. Okay, some people are typing online. X and Y intercept. Now Jordan has given me a good answer. Thanks for writing it like that, because I want to get a point across. So Jordan wrote online here, -2 and 5. And then I saw Alexander is getting somewhere. And then I saw y is equal -2 and x is equal to 5. Now, if you write it like that, Alexander, let me show you something. We haven't gone there yet, but x equals 5 looks like so, and y equals -2 is a horizontal line. You cannot write it like that, or just write -2, 5. What does that even mean? An intercept is an ordered pair, so as such, you have to write it as an ordered pair. You get a -2 here, and you have a 5 here. So your x and y intercepts are 0, -2, and 5, 0. Now, I know what you mean, and on the test I usually don't mark this wrong. However, other instructors will mark you wrong on that. Write it as an ordered pair. 0, -2, where even is that? 5, 0 here. Done. So be careful about that. Now, let's do one more. Which one you want, 42 or 43? Let's actually look at 43. Why not? Because we can. 43, if you find the x and y intercepts, what are they? If you plug in 0 for x, what do you get for y? What? Rodney, if you plug in, we're doing 43, x equals 1/4 y. If you plug in 0 for x, what is y?
0.
If you plug in 0 for y, what is x?
0.
Yeah. So now what? We got 1 point. We can't graph a line based on 1 point. The x and y intercept is 0, 0. We didn't have to do that twice. Now what do we do? Leave?
Leave.
We have to find another point. We have to find another point. We can't just leave it like so, because we don't know, does this graph go this way? Does it go that way? Does it go this way? Who knows how this is going? So what we need to do is we have to find a point that's not the x and y intercept. And the way I do this is I usually pick a point that clears the fraction. So the point that I'm picking here is y equals 4. Why did I do that? Because it cleared the fraction. X equals 1/4 times 4. These guys reduce and we get x equals 1. So you need a second point. 1/4 is right here. You can actually go this way. Here you go. It looks like so. So what I was trying to say is if your x and y intercepts are the same, you got to find a different point. Usually the one that clears the fraction. It's kind of like final least common denominator, similar to that. Okay. What happens if you only have one variable? How do you graph y equals 3?
Just a straight line.
It is a straight line, but what kind of straight line? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, -5. 1, 2, Here you go. Y equals 3. A vertical line. Let's make a t-table. -3, 0, and +3. Why not? Alexander actually said here on line horizontal. If x is -3, what is y? The equation that we're trying to graph is y equals 3. If I make a little t-table here and I put values in for x, if x is -3, what is y, people? 3. If x is 0, what is y? 3. If x is positive, what is y? 0. No, if x, what did I say? If x is positive 3, what is y? It has to be 3. If x is donuts, what is y? 3. This is the equation that I gave you. If x is a billion, what is y? 3. It's always going to be 3, but based on these points, let me graph it and see what kind of line do we get. Some of you said vertical, some of you said horizontal. So -3, 3 is right here. 0, 3 is right here. 3, 3 looks like so. And actually what we get here is a horizontal line. So y equals 3 is a horizontal line. Matter of fact, y equals 4 is what? A horizontal line. If y is equal to 5, that would be right here. Every time when it says y equals a number, any kind of number, just a number, then the graph is a horizontal line.
So is it vertical if it's x equals?
Mm-hmm. And don't you forget about it. Horizontal line. Y equals a number is a horizontal line. So now if we have x equals a number, like for example, x equals 4. If we were to make a little t-table again, and I put in 10 for y, 1, and -25, I just so made these points up. If y is 10, what is x? 4. If y is 1, x is 4. No matter what, y is donuts, x is still going to be 4. And that graph is a vertical line. 4, 1, 4, 2, chip, 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 just like so. Here you go. X equals a number implies a vertical line. And don't you forget it. Vertical line. So if x is equal to a -5, that would be right over here. If you only have one variable. 54, what is 54? 54 is graph -3x equals 12. How do you graph that? Yes, it's only one variable, so let's get x by itself. We're going to divide by -3, so x equals -4. That is the equation that we have to graph, and x equals -4 is what kind of line? Horizontal or vertical? Vertical. What you guys do all weekend? Everybody's so like about to fall asleep. X equals -4. Now, unless you have a good reason like me and watch curling at 3 a.m. in the morning because it's the Winter Olympics, then you should be awake.
It's cold in here.
It's cold in here? I don't know.
It's just your body is saying that you need oxygen.
Well, coming to my age, it's hot every day. Yeah, no fun. Yep, so I don't feel cold right now. X equals -4. I've been watching curling. It was a good game. Sweden versus Italy. Italy apparently hasn't lost yet. No, it wasn't Sweden, it was Canada. And they had to go into overtime curling, and then Canada lost. It was pretty good. I have curled before. That looks so easy on TV.
What is it?
Curling, where you have those, yeah, with the brooms and you sweep, you know. I've swept my kitchen for many, many years. So here we do curling, me and my son. And of course, I could never get that stone to the other side, even if I tried to. So he says, go ahead and sweep. I was out of breath, and I can run, and I could only sweep till, I can't sweep no more. This is hard. Yeah. It was fun. I was more on the ice. I was trying to move, and then you push yourself. It's like, I don't know. But so here we have y2 to be -8 minus what? -2. Be careful about the sign. The minus is in your formula. That always has to be there. Over x2 I called 6 minus x1 was 4. So watch your signs. That's always a common way to make a mistake. Now we have -8 plus 2 and 6 minus 4. -8 plus 2 is what? -6 over 2. That can be reduced to m equals -3. Watch your signs. These minuses here that separate the numbers always because they are in the formula. The rest is depending on what you have given. Okay, how about one for you? Let's not look in the book. Let me make something up. -5, 3, and somebody give me a number. 8. One more. 2. Okay, here you go. Find the slope. Again, if you want to label them, go right ahead. X1, Y1, X2, Y2. Okay, guys, if you have a slope, type it in online. Everybody still awake? We're going to find it here as well. Okay, we can find out. I have no idea. We made up the numbers. So y2 is 2 minus what? 3 over what? 8 minus -5. So 2 minus 3 is a -1 over 8 plus 5 is 13. So your slope is 1/13. 1/13. Ugh. Questions? How about this one? 24. Yes. We have a question, Alexis.
Why is that 13? Why isn't it negative?
8 plus 5 is 13.
Why is it?
Because your x1 value is negative to begin with.
Right.
So you have the negative, that's in your formula, right? So here this was x2, the x2 value was 8, and the x1 value was -5. So you have two negatives here, in between is a minus. 8 minus a -5 turns into 8 plus 5. You can think of it as putting a 1 in there and you have a -1 times a -5 is a +5. And that's how it became 13, positive. But the slope itself, doesn't matter where the negative is, the slope itself is negative. Okay, what time is it? We do this one real quick or slow, and then we are done for today. We're halfway through 2.2. We're going to finish this up on Wednesday and go into 2.3. -8 and 4. 1 and 4. x1, y1, x2, y2. What is the slope? What? Anissa, you got something? What is the slope?
Me?
Yeah.
0?
0? You agree? Michael said yeah. Yeah. You agree? Yeah. What do you say online? y2 is 4 minus 4 over 1 minus a -8, which is 0 over 9. Does it really matter what we have in the denominator? The answer is 0, and when your slope is 0, believe it or not, you have a horizontal line. But we shall talk about this some more on Wednesday. Any questions?